Okay, what is annuity? Annuity is all about making series of payments over a period of time. Example, rent payments, car loan payments. Or it is about receiving series of payments over a period of time, such as receive annual fixed coupons and receive dividends from the stocks. Okay, let us have the technical definition for the word annuity. An annuity is a series of payments made at equal intervals. Take note of the word series of payments and equal intervals. Series of payments because when you deal with the word annuity, you are making series of payments, you are receiving series of payments at equal intervals. It could be monthly, quarterly, or annually. Examples of annuities are regular deposits to a savings account, from the word of regularly depositing your money to your savings account. Monthly home mortgage payment, so you have a regular payment which is monthly payment. A life insurance policy being purchased with monthly premiums, from the word monthly premium, so you are making monthly payments for your life insurance policy. Pension payments, it could be monthly, semi-annually, or annually. Car loan being repaid with equal monthly installment, from the word monthly installment, a series of payments for the car loan. And a bondholder receiving an annuity in the form of semi-annual coupon payments. Here are the primary characteristics of an annuity. An annuity involves equal payments, equal regular payments called rents made at regular time intervals. It could be semi-annually, annually, quarterly, or monthly, and earns compounding interest. So when you deal with annuity, your money will earn in compound interest or having compound interest. The rents payments can occur at the beginning, which is what we call the annuity due, or end of the time period, which is what we call ordinary annuity. Let us define annuity due and have plenty of examples for this. Annuity due are a type of annuity where payments are made at the beginning of each payment period. Some keywords to look for: payments made in advance, payments starting today, and due at the beginning. Moving forward, ordinary annuity are payments which made at the end of each payment period. If a period is 1 month, this means that payments are made on the 20th, 30th, 31st of each month. Mortgage payments are usually ordinary annuities. So let us differentiate future value and present value. Future value refers to the total value of payments at a specific point in time, future value or maturity value. Present value or principal amount refers to how much money would be required now to produce those future value. So I know that we differentiate these two terms in our last session. Next, let us discuss about simple annuity. It is an annuity where the payment interval coincides with the interest conversion period. When we say coincides, payment interval should be the same as the interest conversion period. Example, monthly payments of 5,000 where interest is at 3% compounded monthly. Here, the payment interval, which is monthly payment, and the interest interval, which is the compounded monthly, are the same. Okay, to start, let us begin with the future value of an ordinary simple annuity.
Now, let us take this example. Mr. Yearly regularly deposits 5,000 pesos every end of the year in his savings account with 3% compounded annually. If there were no withdrawals made, how much will be the future value after 5 years? So, as you can see from the word end of the year, it is an ordinary annuity, and then the payment interval is equivalent to interest interval, which is end of every year and then compounded annually. So we are looking for the future value. That is why our problem represents finding the future value of an ordinary simple annuity. And this one, if you wanted to know how much money you have in your investment after 5 years, the figure below illustrates how you would apply fundamental concept of the time value of money to move each payment amount to the future date and sum the values to arrive at the future value. So we will be using this formula. A equals P quantity 1 plus I raised to N, wherein your P is 5,000 pesos, and then your I is 0.02, and then your N for the first year is 4, and justifying the time value of money, that is the money that you have now is worth more than the identical sum in the future due to its potential earning capacity. So for the first year, if you invested 5,000, the future value is 5,627.54. It came from A equals 5,000 quantity 1 plus 0.03 raised to 4. So our N here is 4 for the first year. For the second year, it is 3. For the third year, it is 2. For the fourth year, it is 1. And then for the fifth year, it is 0. So as we go through this process, you can see the concept of the time value of money. So for the second year, A equals 5,000 quantity 1 plus 0.03 raised to 3, and it is approximately 5,460.64. Next, for the third year, A equals 5,000 quantity 1 plus 0.03 raised to 2, and it is approximately to 5,304.5. Next, for the fourth year, A equals 5,000 quantity 1 plus 0.03 raised to 1, and that is equivalent to 5,150. For the last year, A equals 5,000 quantity 1 plus 0.03 raised to 0 equals 5,000. As you can see, the money that you have in the first year has worth more than the identical sum in the future due to its potential earning capacity. So any amount of money is worth more than the sooner it is received. So for the future value of an ordinary annuity, this is the amount of money in the account, including all of the payments and all interest at some future point in time. So if the future value is, or if the future point is at the end of the annuity, the future value is the maturity value. Now, getting the total sum of interest annually, 5,627.54 for the first year added to 5,460.64 added to 5,304.5 plus 5,150 plus 5,000, total of 26,545.68. It means that Mr. Yearly will have a future value of 26,545.68 after 5 years. Now, Instead of calculating that way, let us have the formula for the future value of an ordinary simple annuity. And here is the formula where F pertains to future value of an ordinary simple annuity, R for regular payments of the present value, J for the interest rate per period, and N pertains to number of payments. J also equivalent to I over M, wherein I is our interest rate and M is our conversion period. And then N equals M multiplied by T, where M conversion period and T for term. So here are the given. So our R, which is our regular payment, we have 5,000. I for interest, we have 3% or 0.03. And N equals 1, which is from the word annually. So number of conversion period is only 1. And then T for time is for 5 years. So replacing values for R, J, and N, we have F future value equals 5,000 quantity 1 plus 0.03 raised to 5 minus 1 over 0.03. Next, simplify first numbers inside parentheses. So 1 plus 0.03 is 1.03 raised to 5 minus 1 over 0.03 times 5,000. Next, 1.03 raised to 5 is 0.1592740743 minus 1. So, may minus 1 na siya over 0.03 and 0.1592740743 over 0.03 is 5.30913581, and multiply it by 5,000, we have 26,545.67905. So as you can see, we come up with the same answer using this formula. Mr. Yearly will have a future value of 26,545.67905 after 5 years. Let us now discuss the present value of an ordinary simple annuity. Now, let us analyze this given problem. Mrs. Yearly wants to receive 5,000 pesos annual payments at the end of every payment interval for the next 5 years from an investment earning 3% compounded annually. How much money needs to be invested or to be in the annuity at the start to make this happen? So this is the illustration. So for the first year, he wants to receive 5,000 until 5th year. So her future value for the first year is 5,000. So we are now looking for the money that he needs to invest for the first year up to the 5th year. Using this formula, so we are now looking for the value of P. So to get the value of P, simply divide both sides by quantity 1 plus I raised to N, wherein A is our future value, then I is the interest rate, and then N is the time or number of terms. So for the first year, P equals 5,000, so future value of 5,000, over 1 plus 0.03 came from 3% compounded annually, and then raised to 1 for the first year. So 5,000 over 1 plus 0.03 is 1.03 raised to 1 is 1.03. And 5,000 over 1.03, approximately it is 4,854.37. Next, for the second year, P equals 5,000 over 1 plus 0.03 raised to 2 for the second year, it is equivalent to 5,000. Simplifying the number in the denominator, it is 1.0609. So 5,000 over 1.0609, approximately it is 4,712.98. And then for the third year, P equals 5,000 over quantity 1 plus 0.03 raised to 3, equivalent to 5,000 over 1.092727, and approximately it is 4,575.71. For the fourth year, our n is 4, so P equals 5,000 over 1 plus 0.03 raised to 4, and 1 plus 0.03 raised to 4 is 1.12550881. So 5,000 divided by that number is approximately 4,442.44. And then for the last year, fifth year, we have P equals 5,000 over quantity 1 plus 0.03 raised to 5 equals 5,000 over 1.1592740743. So that is approximately to 4,315.04. And then we need to sum up these numbers to get the total amount that he needs to invest at the start of the term. Now, adding the accumulated interest annually, 4,854.37 on the first year plus 4,712.98 in the second year plus 4,575.71 on the third year plus 4,442.44 plus 4,313.04, and the sum is 22,898.54. It means Mrs. Yearly needs to have an annuity of 22,898.54 at the start to receive 5,000 annual payments after 5 years. Now, let us use the formula for the present value of an ordinary simple annuity. Same variables that we are using compared to future value. So, P for the present value of an ordinary simple annuity, R for regular payment of the present value, J for the interest rate per period, N equals number of payments, where J equals I over M, and I equals interest rate, and M equals conversion period, and N equals M multiplied by T, where T equals term. So as you can see here, we raise 1 plus J, quantity 1 plus J by negative N. Comparing to future value, you are just raising this quantity by positive letter N. And whole number 1, we subtract 1 plus J raised to negative N from whole number 1. Comparing to future value, we are subtracting the whole number 1 from quantity 1 plus J raised to positive N. Now, let us use this formula in solving for the present value of an ordinary simple annuity. Let us first identify all the given. She wants to receive 5,000, that is why the given is 5,000 for R. Interest rate of 3% compounded annually, that is why our M equals 1 and T equals 5 for 5 years. Plug in all the given to our formula. We have present value equals 5,000, bracket 1 minus open close parenthesis, 1 plus 0.03 raised to negative 5 over 0.03. Next, P equals 5,000, 1 minus simplifying 1 plus 0.03, we have 1.03 raised to negative 5 over 0.03. And simplifying 0.3 raised to negative 5 is 0.8626, 0.8784384169. Next, let us have the difference between 1 and 0.862687 843841639, and that is 0.1373912156158361 divided by 0.03 and multiply by 5,000 is 22,898.535935. Thus, Mrs. Shirley needs to have an annuity of 22,898.54 at the start to receive 5,000 annual payments after 5 years.